In the previous video, we have understood how we can store embeddings in a vector database and data ingestion. So we have completed till data ingestion. If you guys don't know this, please, I have put the link in my description so you can go and watch how we do the data ingestion. In this video, we are focusing on retrieval process. So here for retrieval, first step is to make your query and create embedding with the same embedding model and then retrieve from the vector database which we use as a Milvus and take top 2 or top k documents, and that is your context, and you write a system prompt and then becomes argumentation. Then together we give to the LLM model with a context prompt and a query, it will generate the answer. So now our first step is to embed the query. So I will give a query like I have a headache, I don't have a painkiller, I have a $650. Can I take it now? I'm using the same embedding model and I am creating a embeddings. And you can see embeddings here. These are the semantically understood floating point values with a dimension of 384 which we defined earlier. After you create embeddings, what you can do, you can send that embedding to your Milvus vector database, and we have to set some search mechanisms. Before that, I just give a recap of how we created this database. So first step, we did the collection setup, which collections, and then we defined the schema, and then we set up the which indexing method we have to use. So these we have set in a data ingestion process. Now I have to get the near I have to get retrieve the document. How you retrieve the documents? For retrieving documents, we use approximate nearest neighbors search, ANN search. So whichever are near to that particular, this is your query. This example, this is your query, and this is your relevant answer for that, or like semantically related answer, which is near to that. It will provide the document outside, and how many documents we can configure it, and at the end how many documents which are near to my query it will retrieve. So for that I am giving the top k as 5 and using the same vector database with a search and collection name, and query embeddings I am passing it, and for approximate nearest neighbor search I am giving it as a vector, and limit is top k, and search parameter I am giving the same matrix type which I had earlier defined when defining a schema and indexing methods. Okay, then what I am doing, I am see, always it will give the results. Once it give results, the format will be, you can take a hit. In the hit you will get it a distance means how close this retrieved document with respect to the query you have asked. That will be in a similarity score, that will be from 0 to 1, and text, whatever the text it has, text will be in the entity, and the source also will be in the entity, and remaining metadata you can extract. So now I will print those. So you can see here your question was, what your question was, I have a headache, I don't have painkiller, I have $650, can I take it now? And it retrieved the document from vector database with which is a near one is the this one with a score of 0 points, means whatever the highest score means, if it is a score 1 means it is very near to your query, means very semantically related or similarity to this your query. So you can see the source, and then you can see here this is the chunk returning as a first retrieved document. Similarly, the second one is sick with a 0.6557, and the text is this. Like that, we have limited up to 5 documents. So you will get first 5 documents in highest score to lowest score similarity scores. So I am making it as a function retrieve documents. Now your retrieval step is done. So till here you are done now. So next what? This retrieval document you will consider as what? Context. And what you will do with the context, what you will do? You will write a system prompt. And that step is called argumentation. And here you can see I am writing a function build drag prompt where I am passing a query and I am passing the retrieve document. The retrieve documents is nothing but all the retrieve documents, nothing but a context and system prompt I am writing like you are a medical QA assistant and I am putting some strict rules. Only provide answer within the context, don't give outside and do not use your outside knowledge. If you don't found a context, say the provided document doesn't have this information. So I had given a strict rules. This is a system prompt. This is a context. Together it is called as what? Argumentation. Now after argumentation, next step is that give that argumentation and query to what? LLM and it will generate the answer. Okay, so here I have written that, but here LLM, which LLM, how to get this LLM? So earlier I mentioned I am using Groq API key. So you can go to https groq.com. Once you go there, in that in developer option, pre API key, and then come to here, create your API key, display name something, no expiration, verify your human, then submit. It will create the API key so that we use it as a LLM. Just copy and then in your secrets add your Groq API key in a value and make a name as Groq API key and enable it for this, and then so you use chat Groq and provide which LLM you are using, temperature and API key, and then run it and we will see what will be the output for this. Yes, you got the output. Yes, you can take Dolo 650 for headache. According to the guide, Dolo 650 used for headache and dosage is one tablet every 4 to 6 hours. You can take it with or without food with water. And this answer is generated from the context got from all those 5 retrieved documents. Now you are built a RAG system with an internal document of pain medicine guide. Now you have built a RAG system with one internal document, PDF document. So now what you have to do? You have to go this Google Colab in a reverse order. First try to change temperature, max resize, then change the model and then go for again retrieval and change the matrix type, change the NNS field, and change the database if you are required, and just do exploration, plat, HNSW, and instead of one document, PDF document with 3 pages, take a 100-page document and then analyze it, chunk it, store in database, and then do an experiment with that. After you are very you are very clear about the concepts, then change the document type. Instead of PDF, try with docx, PPT, or you can do with the external sites. Take one page, take HTML data, then change it, then chunk it, then use all this and just experiment with this. But this Google Colab page, what I am sharing here, this I will provide it in my GitHub repository where I am providing Google Colab link. I am adding the basic pain medicine guide PDF and even I am providing my YouTube channel link. So please go and understand and experiment with this, then you become RAG expert. Instead of reading, listening many YouTube videos, just go to this Google Colab, change the values, change the databases, change the document, and experiment with this. Once you are done with this, then we will use this RAG application wherever I have mentioned, right? This is the RAG application. What we build, we will make it as a tool. These all whatever I am mentioning is tool, okay? So with these tool, we will create agents, React agent like pain medicine agent, web agent, computation agent, research agent. Then we will have a router agent, supervisor agent, and we will build this complete multi-agentic systems. I'll be uploading multi-agent in playlist of Pragmatic Gen AI under my YouTube channel Shivraj Mokashi. If you have learned something, please do like, share, and subscribe to my channel for the videos which will make you to gain knowledge of the current cutting edge technologies.